right, welcome folks to another amazing SNIA Experts on Data podcast. My continuous pleasure to be a host of this fantastic community, and this is going to be a great one, mostly because there's a plethora of Erics available on this call. That isn't always a requirement. I like to have a 2 Eric minimum, so it's even better that we got 3+. And Cal, you'll be an honorary Eric today. So for folks that are brand new to what we do here, so SNIA is an amazing community that I love the fact that we're sharing so much information with our technology world, both in the community and beyond. So my name is Eric Wright. I'm the co-founder of GTM Delta and also the host here of the SNIA Experts on Data podcast. And I'm welcomed by 3 other amazing humans. We're going to talk today about an amazing webinar that talked about vision AI. And this is a deep dive that I took a look at the content that is going to be in here. And this is what we need. You know, people always have questions and they want to be able to get to the good stuff and they want to go deep, but also understand the why. This is such a beautiful merger of those 2 things. So we're going to have a bit of a chat about, you know, the subject matter. And of course, we've got links down below to point to, you know, getting in touch with the folks here, as well as seeing the webinar itself. So with that, I'm going to get onto the good stuff here. I'm going to start. So Eric Smith, if you want to introduce yourself for folks that are new to you, and then we'll make our way around.
Sure. Thanks, Eric. Eric Smith. I am a distinguished engineer, and I work for Dell as a member of their CTIO team. I am also the DSN Data Storage and Networking Communities Chair. So that's a SNIA community that is sort of sponsoring the AI Stack webinar series. Thanks for having us. Yeah.
And Eric Gamble, just so I keep the Eric flow going.
I'm Eric Gamble. I work with IBM. I am an AI technologist, and also I do, technically it's data science, but it's in the area of AI modeling and predictive modeling. That's my specialty. I spent 4 years, in addition to my day job, as an adjunct professor with Wake Forest University doing graduate analytics course.
Fantastic. And Cal?
Thanks. So my name's Cal Foshi. Unfortunately, I'm not one of the 3 Erics here, but I also, like Eric Gamble, work for IBM. My day job is the storage procurement engineering manager. I manage our team of engineers that work with our suppliers, but I'm also one of IBM's subject matter experts in computer vision, and I do that both for internal use cases and with clients.
Amazing. Excellent. All right. There's a reason why I call it Experts on Data. We got experts in the room. So Eric, Eric Smith, I'd love to have you talk about the webinar series really quickly. Like what is the value of the AI Stack webinar series, and what else have we already talked about, and kind of what's coming up? Because for me, I'm excited as heck, but I'm a bit of a captive audience here. So let's tell the rest of the world about it.
Yeah, so thanks for the question. The AI Stack webinar series is really about introducing people to the basic concepts that are involved with AI. We started with an intro to AI ML concepts webinar that included a binary digit trainer and gave people an overview of how actually training a model works. We've subsequently followed that up with a webinar on inferencing, which was a few weeks ago. We've also done one just now on training a model, like the actual model used in production, and one for vision at that. And it was a phenomenal session, and I think everybody should check it out. Going on in the future, though, it really becomes about how do you practically deploy AI ML solutions. You know, what does it take to deploy a model? What does it take to use it in inferencing? How do you set up an environment such that you could run a model? You know, what's the hardware requirements? All those things. And you know, there's going to be a practical webinar coming up that's related to you know, creating a chatbot. You know, that's based on RAG. So it's, you know, we've got a bunch of interesting things coming up here over the next year.
And what I really adore about this, and I'm blessed to be a part of this community, is that it is such a very strong community focus around education and around engaging and connecting people, because we are birds of a feather and we are all trying to solve similar problems for our friends, clients, customers, et cetera, and really advance the world through, you know, shared standards and shared outcomes and what I love about this is even though we all come from different brands, when we're in SNIA, that's all that matters. So very, very cool to see the webinar and many more like this. So maybe I'll have you start off, Eric Gamble. Let's talk about the vision challenge and what is really sort of distinct about vision AI and where this is an important piece of. This isn't just like every other AI. When people, unfortunately, when we say AI, the first thing they think is, we won't even say it. It's the iPhone of AI, right? We think of generative AI and they go to immediately a brand. But it's not that. And especially beyond generative chat stuff, vision is fundamentally different. So I'd love to get your sense on what are the challenges and what are the kind of cool breakthroughs that we're sharing through the webinar.
So one of the unique things about vision, I like to characterize AI as not being a problem of ones and zeros, but it's a problem of getting, or I should say it's a challenge of trying to get ones and zeros to behave like people. And in the human context of this, vision is something all people can relate to as far as that goes. And as far as trying to understand how models work, how we would process algorithms, how we would do prediction, we can do a lot in the education space just by talking about vision and trying to put that into action. So in our specific case of computer vision, one of the challenges we went through in the webinar is these algorithms operate at a low level. We're talking in the ballpark of 600 by 600 pixels. Well, when you go buy your high resolution iPhone or Android, what do you do with that? And so Cal and I can talk about that more, but the reality is that just like a person, like when we're staring at a high resolution image as a person, these algorithms are going to downsample, upsample pixels just to fit their models. But as people, we process it whatever we see, good or bad vision. And so we're able to make all those decisions. So the real challenge is, how do we, knowing that these algorithms work the way they do, knowing camera technologies, knowing everything else, how do we really get it to work like a person and as good as a person? And one of the benefits of that is once you actually can do that and automate that, now where an AI model can operate in a way that a person can't. Like, I'm going to get tired. If I did this for 16 hours, my eyes are going to get really tired. The AI model doesn't get tired. It will perform consistently. So there's a benefit and a bridge once we figure out how to do this.
Well, that's a very interesting thing. And even when we talk about LLMs in general, it's tough for people to map like what it's trying to achieve and the way it behaves. And then we sort of complain like, oh, it behaves this particular way. Like, we've told it to behave. It's representative of the training data. Like, there's a reason. And unfortunately, it's also the average of us. So it's not always the best. And it will take the average. But vision is such an important thing because we do this today. So I've got a green screen, which no one can tell other than general lighting over my head. And even when I do camera work, we use things like depth of field. And quite often, a lot of podcasters and even cinematographers, they lean on this idea of like, we use depth of field to force focus into one area because we're trying to tell the person this is the only thing that should matter to them in the image. And we like forcibly move people towards that as humans trying to create this. But meanwhile, the human eye takes in about 1 trillion objects in the scene at any moment in time. And like you said, Eric, like we can't even process that, but it's there, it's being consumed. And now, so this is interesting. And I'd love to have you sort of keep going on this idea, Cal, or either you or Cal, and like, what are the limitations and why is this neat and how computer vision takes this on?
Well, so you just hit on something here as far as all the processing. So a lot of it is signal and noise. And we don't think of it that way. We just look and we see and we process things. But the reality is that in our heads, we are targeting signal and extracting noise all the time at a very high rate. I'll let Cal to jump in here.
Yeah. So, as people, and this is an aspect of humanity that we often don't talk about, we have our senses, our sight, smell, hearing, taste, feel. Oftentimes those senses are more effective at filtering out information than about gathering it, right? You can see and hear and smell a million different things. We have developed as people to understand what we need to be listening out for, right? We need to hear that tiger sneaking up on us. We don't really care about the birds flying in the trees. The computer vision has none of that evolution, that background, that context, right? So as modelers, we have to figure out how to either give the model that context or to simulate it. One strategy we use often is, let's think of a door. You might be wanting to see, is the door locked? And to see if it's locked, you want to look at the handle and see if it's turned in the lock position. Us as people, we can immediately look and see a door and we focus in on the doorknob, but the computer vision doesn't know how to do that. So we may first teach it what a door is. Hey, this is a door. Yeah. So take a picture of the room, find the door. So it finds the door. Then we have another model. It's like, okay, now that we've found the door and we've eliminated windows, we've eliminated open entrances and exits, we've eliminated posters, all things that are rectangular that the model could get confused by. We've eliminated those. We just have a door now. Now we have a model that says, go find a doorknob. And that model specifically goes and finds the doorknob. That's all it's doing. And then we might have a third model. And that model is what's looking, is it in the locked position or the unlocked position? Now, to a user who's taken that picture, they probably don't even realize all of that's happened. All they know is that at the end of the day, their inspection told them the door is either locked or unlocked. We've used a series of simple models, a model that just finds a door, a model that just finds a doorknob, and then a model that looks for the position of the switch. And as Eric talked about with signal and noise, we've eliminated all of that other noise in the room, all the windows, the posters, the entryways. We've eliminated things that might be on the door, right? The panels, the windows, the deadbolt, if that's what you're looking at. And we've narrow focused it, but the model wouldn't do that itself. So we had to train 3 models to narrow in what you or I would naturally do, just because of all that context we have. We know what a door is. We know what a doorknob is, right? We don't get confused by the window, but the model does. And that's a key part of filtering out all that extra noise for the models.
Yeah, I just wanted to jump in. That was actually one of the things that I walked away with the webinar really having a healthy appreciation for was, they introduced the concept of multiple models and how each model, as Cal was just walking us through, how each model does things progressively and the value of doing that. And I didn't have a good appreciation for that with vision models specifically, but I think that's also, there are many, many other applications of that same concept. So.
Well, that's funny, Eric, when you say, I was thinking even from your side, we've seen so much stuff that we've done where at the very sort of standards and methods level that we're seeing that's happening. But then when we get to the very specifics of inside how the outcome happens, what are the technologies and processes to get there? And, it's not even about taking in more, but in fact, in this case, it's about eliminating the noise quickly. And we're seeing, LLMs that are then being augmented with SLMs and other ways where we can get very purpose-built things. And like I said, humans are interesting. Like I said, when we see things, it's obvious and it's completely obvious. We know exactly why things behave a certain way, but even when that's the case, we're still wondered by it. And what we miss sometimes is the LLM and these models are dealing with that wonder, and they have to also then present it. And we have to, as model builders and how we build these systems, we have to extract the very human required elements from them, because we can't just, take it all in and ship it all back. And we're a long way from, Blueberry Muffin or Pomeranian, which is where we kind of all started with that vision of can these vision models actually work? I know every time I accidentally lose my security key and I have to do a CAPTCHA, I'm like, really? We don't know what a fire hydrant is yet? We're still doing this thing? But it's because we have to continue to tune, train, and that stuff all has a purpose. People often forget that those CAPTCHA models are not just for us. They're doing a neat thing behind the scenes. So Eric, I'd love to hear, what is it that we see that we do now? What are some of the methods, things like understanding what is the bounding box? How do we manage for labeling? There's so many intricate activities that are happening in how we achieve the end result with Vision AI. So maybe walk through a couple of the technical hoops that we're jumping through.
Yeah. So just as a background, one of the things we have to stay focused on with AI is that it really, at its fundamental core, it's about patterns and detecting changes in patterns. And all the other stuff is built around that. So on bounding boxes, they're simply rectangular. And most of what we do in the world of, I'll say, object detection, which is the bulk of this, and even in classification, it's based on rectangular boxes. There is an area of detection known as segmentation, where you can draw polygons with lots of sophisticated shape cutouts and stuff like that. What happens is that if you actually do all that sophisticated polygon work and feed it into an object detection model, like I'll use YOLO. I use that a lot in the presentation. It's just going to make it a box. It's going to take all your time drawing and just box it. So you have to be aware of tools like that, because some of the tools out there don't advertise that. But the key is that think of this box as a signal and noise thing. In a way, one of the strange metaphors I use is that if you are a baseball player and you're a professional batter, you work with the batting box. If you had the ability to force that pitch where you want it every time and inside that box, you would do that. That's our goal. That's what we're trying to do. We're trying to create these models that can really fight inside this box and do really well. So in some ways, like if we sit down with a client tells us, I want this model to perform with an error rate of, I'll say, 1 in 10,000. A lot of people would stop and walk away from the table at that, especially with vision. The reality is you have to assess, well, how could we do that? And this is why we go back to the systems of small models as far as we can very effectively get these models to do a task really well and then pass the next task off to the next model. This is how we target those error rates and work that into that range. I've kind of stepped away from the question on the bounding box, but that's essentially what we're trying to think of in the bounding box. It goes back to signal and noise and patterns. So we want that box to be signal. We don't want a lot of noise in there. We put a little bit of noise just to keep margin on it, but we want to box in the pattern. Now, when we say a pattern, we have to think in patterns, and sometimes those patterns are like if I use this in the example there, the Coke bottle. Well, maybe the only thing I care about in my decision is the bottle cap and the label. Well, maybe my pattern just needs to tie on that and leave everything else behind. Sorry, I'm not trying to advertise for Coca-Cola. Just an example there. But the point being is that you think in patterns, and you want to think about signal and noise, and just get rid of noise all the time. All the time, get rid of noise.
And you're trying to make it, like, as you said, like we want these things to behave in a human way. And the part of it is we're learning how humans behave as part of this, because we don't understand fully, like we're building neural networks and we still have to figure out where the end result is, because we don't quite know up here exactly how it works. We're very far along thanks to a ton of really amazing research. But isn't like with vision, even simple things, I tell people there's assumptive things that we do when we look at a scene. And people, it's a small thing that people don't realize, but we have to get rid of those assumptions. How do you train around that human problem?
You want to take that, Cal, or I'll take it? It's up to you.
So training around a human problem is always one of the biggest things that we have to do. And a big part of what Eric and I do is also teach people how to use vision tools. So he and I are experts in it, but our overall goal when we work with clients is that they end up being able to do it themselves without us. So to teach how to overcome the human assumptions is a challenging one. A big thing we run into is, and this is especially with engineers that we work with, are good and bad. They want the model to find it's good or it's bad, and we have to remind them it's about patterns, right? We can find a pattern. We're going to teach you how to find a pattern, a distinct pattern. Now, this pattern may represent a defect in your manufacturing process, but it's in itself not good or bad. It's just the pattern. Once it's just the pattern. And once we get the engineers or the modelers to start thinking in patterns and get that kind of mind shift from a, go, no go, good, bad to a pattern A and pattern B, then you can really get some cool things going with your inspections because you're not limited to that binary thinking. Because maybe you have 3 patterns for good and 4 patterns for bad. And so you may end up with 7 objects where you're really just trying to say, this is a good piece of equipment, this is a bad piece of equipment, but you end up with 7 different objects that you have decisions to make on. And that's the key one. As Eric said, it's all about the patterns.
Yeah, and what Cal mentioned there, this is another strength in how you approach the modeling, is that if I have 3 different patterns of bad, I don't care if they get confused. I'm trying to reject on bad. So there's actually modeling techniques where we strive to drop the accuracy down, because all the models are going to have error, but if we can bucket that error, like bucket a lot of the confusion and the bad among the bads, and bucket the confusion of the goods among the goods, that's the game. That's what we're trying to do. So some of this is gaming the algorithms and trying to figure out how to do that and pocket the error.
That's an interesting one too, because you think we were a long way from hot dog or not hot dog to like being able to say, is this a manufacturing deviation that could lead to a rocket exploding when it's pressed by heat, and being able to use that vision. But part of not just the capability to do it, but to optimize the compute required and the time required to do so. And I think this is one of the most amazing innovations we're seeing, and certainly in the SNIA organization and far beyond, where people are coming together we've already got the thing, but now how do we make the thing better, accurate, faster, cheaper, ethical, and safe? There's a lot of other criteria now, because as you said, we could just, if I take a vision model, do I need to see the whole scene, or can I narrow the focus on setting that bounding box to a particular area or whatever? There's minor things, or using multiple SLMs and some kind of agentic handoff between that could, in the end, mean that we use less compute, less power, where we get higher accuracy. There's many, many ways now that we are testing, because the fundamentals, I think, are pretty sound, but now we can really experiment. What's the fun you're seeing around some of that stuff, Eric?
Well, so in the vision space, I mentioned the yellow models, and they keep evolving. And I'll use an example like YOLO version 3. I mentioned in the webinar that there's no licensing fees to use it in production, but if you use version 8 or version 11, there are. The gain from that is as these algorithms evolve, some of them are faster, some of them are more accurate, depending on the use case. And so that whole idea of total cost to do the inferencing, or total cost as far as time and compute to do things, it does make sense to play with, I'll say, the shiny new golf club. Go test the new tool, see what they can do, right? Take those use cases, test them again and see if you can improve that. A lot of that can ripple out into benefit and savings.
And from that, maybe, Cal, how does that evolution of a model, play out? And how do you define the start and finish of some type of tuning evolution, and it is now better than it was? When do we see this goal achieved? when it is there's a lot of places where you could go. It's tough to measure in my mind.
Yeah, so the evolution of a model is always a fun one to talk about. So to evolve a model, that's the primary job of a modeler, the one who creates the models. And you might be evolving that model in a few different ways. A common one we have is we have it running, testing it, and we see that it may work really well on pictures captured during the day on the manufacturing line, but at night it still gets it right, but the confidence score is lower, right? It was 97, 98, 99 during the day, and it might be 88, 89, 90 during the evening. Still correct. Everything's going, and if you weren't looking at it, you wouldn't know. But that lower score suggests there's a weakness in the model. So the next evolution would be you take those pictures that were captured at night, you correctly label them with the bounding boxes like Eric talked about, and you retrain your model with those new images. Now your model is better trained on what it was previously weak at, right? Those nighttime images. You test that model. If it's good, then you deploy it, and that's now your new main model for your inspection. Now, I like to caution people here, a lot of the applications that create models will have a feature that may allow it to tune itself. This is something that that Eric and I will warn against. And I like to quote Dr. Malcolm from Jurassic Park. You know, you were so preoccupied on whether or not you could, you didn't stop to think if you should. Now, you can let these models update themselves and evolve themselves. Our warning on that is your original model may have had an innate error in it. And that error is going to propagate every time it iterates itself. And if you're not paying attention to it, if you're not observing it or overseeing it, that error is going to get worse and worse and worse. I'm sure we've all seen it, you know, playing with some of the different AI models online, right? You feed it a picture of a duck and say, redraw this. And then you keep feeding it the redraw. And before long, you don't have a duck at all.
Right.
And that's because that little error that was in its first one gets bigger and bigger and bigger. The second part of a self-evolving model is one of the key jobs of a modeler is understanding what the model does and how it works, where it messes up and where it works well. If the model's changing itself, you're going to lose that knowledge on how this model functions, and you may not be able to deploy it properly to do what you want in your inspection, right? We have our model that finds the objects, but then we have the inspection that takes the findings, the objects that you found, and makes real life determinations, right? Sometimes it's shut the line down, and the quickest way to get your inspection turned off is to shut a line down when it didn't need to get shut down. So we advise, at least in our area of expertise in manufacturing, don't usually let your models change themselves. It's much better to have oversight from somebody who can see what's happening. And then you asked about deploying a model. I'm going to keep it fairly simple on that. It's going to depend on your use case. Sometimes you have use cases that need 99.99% accuracy, right? You're spitting out 1,000 vehicles a day. You are 99.9% accurate. Well, that means you're losing one vehicle a day, and that vehicle might be worth $70,000. So 99.9 is not good enough. You have other use cases where the client has really no way to find these defects. They might be dents, scratches, corrosion. It could be partial seating of connectors. And if you can find 80% of the most common ones, you're helping them out a ton, because those 80% of errors wouldn't have been found any other way. So for that, you're a little loosier and a little goosier on what you allow. You're going to focus on your middle 80%, 80% of the most common defects. For that 99.99%, you're really stress testing it with those edge cases, because those are what's going to trip up your model. Once you feel like you've tested enough, you let it run, and you monitor it. As I said, you got to watch it, see where it's performing well, see where it's struggling.
It's
I'm going to add to that.
Yeah.
So there's a ton of iteration in this, and Cal is kind of explaining how we do that. There's also diminishing return, And so as we're doing these iterations, we want to try to do them quickly and take big chunks off the table. But once we get that in a range where the return is diminishing, we push that more to maintenance type of effort. But versioning is a key thing too. So as we're doing these iterations or even changing models over time, if I need to get back to where I was 6 months ago, that version needs to be there. That ability to go back to that version. People who jump into this and just keep iterating and changing and don't do the versioning work, eventually you'll regret it. Eventually you need to cling to that and go back to that to reset.
Yeah, even in like code generation, this is one thing that people often have the problem with. Eventually, the good code gets rolled off the back, and you no longer have your sort of safe reference. And with vision, it's so different, especially because the real-time aspect of what most vision stuff is doing. It's a very like generative AI in the text sense. Yeah, we want it to be fast, but it's crapping out words at a reasonable rate to keep up with human consumption is not hard. But being able to consume, process, and then inform somebody based on vision that's happening in real time, especially in a manufacturing sense, like the chance to suddenly like pull the line, without having a human have to see the thing, that has to be something that happens in real time. And there's so much difference in the efforts to train and the challenges. So when you have clients and folks that are like saying, hey, don't I just take a foundation model and just keep going? Like, what is the surprise that you hear when you could tell people this is what training will look like as we begin to implement?
So the biggest thing, especially when we're training clients for the first time, that whole bridge of thinking and patterns, we go back to that because, again, they make a lot of assumptions in their head. We do, so it's interesting. When we're training, we make a lot of mistakes. We make a ton of mistakes creating models. The key is not to cling to bad assumptions. If you're wrong, you're wrong. Pivot fast.
Yeah.
And don't. It's not a fight to be right. It's a fight to get it to work and have good results.
It is important that we keep that objective, and then now connecting the technology and the methods. Just to go, Eric Smith, you've probably seen a lot of people even taking this content in and learning from Eric and Cal and folks in the community. You probably are seeing people that are like, oh, like they may be hopefully surprised and educated and easing their journey, who are maybe not working directly on foundation, or they just want to consume the stuff. But as other technologists in the community, what are some of the fun things you're hearing back when people are hearing, these type of tips and tricks?
I think that's a great question. Let me start with sort of what I was surprised with, what I've been surprised with the the feedback that we've gotten from the sessions in general, and then I'll go to this one specifically. I think people really appreciate understanding how the technology kind of works first, getting a really good hands-on sense for what they can do with it, and this session was perfect for that. We spent a lot of time looking at rectangles and talking about what some of the challenges with working with each sort of picture, granularity, scale up, scale down of images. I mean, it was really interesting. But one of the biggest surprises for me came when we were talking about planning the session, and we had started off with this idea that we would have a training webinar. And let's train a model. And so I trained a simple binary digit classification thing in our very first session. And I said, well, let's just, we'll have on an expert that's from an expert with LLM, and then Eric and Cal experts in vision, and we'll just do one session on training. And it was clear, excuse me, it was clear that was not going to work almost immediately because of how wide the topic was. And so we focused on vision. And the other thing that I took away from this session, and in general these sessions, are that a lot of the concepts are transferable, not exactly, but a lot of the principles are similar. I like the idea of failing fast. I like the idea of not getting hung up on a specific assumption, being very flexible and willing to pivot. All those things are very important, I think, and they're common. And yeah, so I think that's really just sort of giving people a basis to sort of build upon and understand the differences between training a large language model and a vision model has been was interesting just from that perspective.
And maybe, Cal, I'm going to call on you. I'm going to take you into a deep, dark topic, because one thing we hate is when text shows up in images. Holy heck, it's the most brutal thing to consume, because there's a lot of risk in how it's text is treated not as text. We see it like, I as a human, I see that's a word and I treat it like a word. But we then have to train vision models to be able to do that amongst graphical thing. And this kind of touches on OCR. I'll say as an example, like even if you do OCR like this or like this, it will fundamentally change the accuracy. And so I've even had folks that they say putting in documents and making sure that they are in the directional format will speed and also increase the accuracy when consuming and rendering text out of data with OCR. So I love to, how does the text in images and OCR kind of come into play when we're looking at the vision challenge?
Yeah, it is can be a deep, dark topic. Eric and I have banged our heads against many of walls over the years when it's come to OCR and text-based use cases. One thing I'll throw out there to begin with is don't be hesitant to use existing OCR technology. It's a form of vision, but it's a honed in, focused form of vision, right? It can recognize digits and numbers, letters, versus maybe a more generic vision algorithm can be trained to really see anything. Now, that's not to say you can train almost any vision model to learn what letters and numbers and characters are. But is it going to be better than an existing OCR that's open source that you can use? Probably not. It really depends on the characters, I suppose. You talked about, the rotation. That's a big one. So we've actually had models specifically to see, is this rotated the right way? And if it's not, you have code to rotate it before it even gets fed to an OCR. It goes back to what Eric talked about, like a baseball player, right? If I could stand up with my bat and say I want a 70-mile-an-hour ball right down the middle, I'm probably going to hit it almost every time because I know exactly how fast it's coming in. I know where it's going to come in. And that's what our goal as modelers always is, no matter what the use case is to get that consistent pitch, same speed, same place, same time, every time. Then the model doesn't have to work very hard. When it comes to accuracy of OCR, there's a lot of tricks in there. Eric and I had to become experts in regular expressions when dealing with OCR, because again, we wanted to tee it up for the model. We knew we were looking at a serial number, and we knew it followed a pretty specific alphanumeric pattern. Could be any amount of letter or numbers, or any letters or numbers, but it went in a specific pattern, number, letter, whatever it is. So we use regular expressions, or regex is what you might see in the industry, to tee it up for the model. Hey, you're going to see 3 letters, and then you're going to see 4 numbers. And guess what? The 3 letters the letter will never be O or A, or whatever the rules were there. And those are all just little things. You have to become experts in a lot of random areas to really get these effective and functional models, because it's all about reducing the noise, increasing the signal.
Yeah, just to add to that, when Cal and I get called in to do modeling work and help teach people, they are focused on making these work right, not just good. They want them working really, really well. So some of the techniques he's talking about are what we do.
Yeah, and I think this is there are so many people who their exposure to this stuff is basically one-shotting off of a foundation model that's in some service that they don't understand what the training is, and even like one thing that became very good early on, of course, was being able to generate human figures in certain ways, but there were certain things that were challenged.
I literally could have hold up my hands.
So I wanted to get, there's like somebody sells this thing. It's like a little fake finger you put underneath, and so you just wear this in any place you are. And if someone says, "Hey, I don't like what you said," they're like, "Oh, that was an AI generated video. Look at the extra fingers. That wasn't me." So there's a great way to get out of crime cameras, I suppose. But the other challenge was the reason why those things are very good at generating human figures, not necessarily the fingers and toes, is because they were generated off of a lot of training data that had a lot of human figures in it. I won't go deep into what that was, but there's a lot of training data that you didn't have control over that led to that first foundation model. And then now, what do you do with that? And this is why anybody that's thinking of getting started, it's not just grab some latest and greatest model. You have to understand what led to the current state. How do I make this, achieve my first goal? And then how do I continue to evolve myself or this model or my process, which is, there's a lot of stuff that we don't necessarily know about what got us to step one.
Yeah. So if you're in this line of work for long enough, one of the key skills that doesn't often get talked about is your ability to break things. I don't necessarily mean, grabbing a hammer and smashing something, but when you have a new technology, one of the first things we do is we ask, how do we think we can make this not work properly? Where do we think it's weak? Where do we think it'll get confused? Because you can't properly use a tool until you understand its full limitations, whatever that tool is. Right? If you try to hammer in a screw, that's not going to work very well. It's the same thing with these tools. Some of them are amazing. A lot of them are amazing, but they might not be good at some specific thing, right? So you talked about the generative AI, and it was having trouble making a five-fingered hand consistently, right? But it did a lot of other things really amazing. So if we're using that tool and we understand that limitation, we might be asking to generate images that don't have people's hands in them. It's the same for any other of these AI tools, these vision tools that we use. It goes back to Einstein, right? If you judged a fish by its ability to climb a tree, it wouldn't seem very smart. The key is to break the tools and to understand their limitations. Because if you've broken it, if you know how it won't work and you know what it's not good at, then you can really deploy it in a way that it's going to be effective and that you're going to get the full value out of it, whatever its ceiling is. You want to get there.
I laugh at what Cal said about the braking because I coach high school track and field, and I'll have kids ask me, so what do you do for your job? And so I tell them, I said, well, I break AI so that we can make it work.
That's awesome. Well, I'm glad that I got fine folks like you both breaking AI so that we can make it work better. And I only wish that I could go 8 hours and keep on going with all of y'all. So thank you very much for sharing what you did. I don't want to take away because you talked about a great stuff in the webinar. So we'll have links. So people go check out the webinar, stay in touch with the series. We'll also make sure that we have links out to folks that are here on the podcast, because this is stuff this is a really exciting topic. And I love that in the SNIA community, there's opportunities to keep participating and having these conversations. So I look forward to that. I always tell people the classic thing, if you don't think that we do certain assumptive things with vision, it's a very simple test. Everybody knows what an elevator is. We know how it works, and we trust that it generally works as expected. But if you think that your trust in that output is so good, then what I want you to do is I want you to go up to an elevator. I want you to turn around backwards. I want you to press the button, and I want you to close your eyes. When you hear the ding and you hear the door open, I want you to jump in backwards. You are never going to feel a feeling like that moment in your life, because what's the first thing you do when you get an elevator? You check to see the elevator's there. You don't know you do it, but you do it. And if you don't do it, you know why you do it, because your heart will make motions that you've never experienced on any roller coaster as you jump backwards into what you know is an elevator. I don't suggest people do that just in case there's no elevator there. So we're on that. I recommend a friend is there just in case. But that tells you this is a very challenging technology problem that has a very human element to it, and tech will get there with human help, and it will continue to bounce off back and forth between human and tech. And this is the value of kind of what these folks are doing. So with that, I'll ask you both or all to kind of sort of do a quick wrap and remind folks where we can find you and any quick exiting words as well. Eric, Eric Gamble. I'll go around Robin here.
With any analytics, any of the modeling, whether it's AI, whether it's vision or just basic AI, comes down to patterns and changes in patterns, and go back to that core concept every time.
Absolutely. Awesome. And Eric, if when folks do want to get connected with you, what's the best way to do so? Beyond, of course, we'll have some links to your SNIA persona, of course, and people can get to the SNIA events, and we'll be able to meet you IRL, hopefully. But what's the best way to catch you online?
You can catch me on LinkedIn for sure. You'll find me.
I love how LinkedIn became, like, unironically my favorite social media network, because they all disbanded. Everybody disappeared off the other one. So LinkedIn is the last bastion.
yeah. There's multiple of me out there. I think you'll see my background right now has a track on it. So
nice. All right. And Cal, where what would you leave with the folks before we go, and where do we find you to keep this conversation going?
So I'm going to steal a quote that Eric used in our presentation, right? All models are wrong, but some are useful. And that's, if you can remember that going into any models you use, but in my case, vision models, you'll be successful. The models are never going to be perfect, but if you understand how they can be used, you can do a lot of cool things with them. And if you need to or have any interest in getting in contact with me, LinkedIn is also the way to do it. There are not too many Cal Foshis on there, so it shouldn't be too hard to find me.
Nice. Well, it's like the old saying, democracy is the worst kind of government except for all the others.
Precisely.
And we have to really, it's fun to contextualize this, because that is exactly it. Like, we just make this like everything just works. You're like, well, assume it doesn't, and then work upwards from that assumption. So, and Eric Smith, of course, last and certainly not least, where do we find you, and what do you want to share with the folks about this session and what we've got ahead in 2026 for the SNIA community?
Sure. I'm not sure if you can hear me, but the headset just have a thing. I would say, go out and break things. Seriously, go out and break things. Try doing things. Fail fast and see what works and what doesn't work, and you're going to learn a lot. And that's I think the best way to get introduced to AI and the topics in general. We have a great set of webinars coming up. Consider going to them, looking at the demos, and the best way to get a hold of me is also on LinkedIn. So, thanks, everyone.
Fantastic. LinkedIn's where the party's at, and if you want to connect with me, there's way too many Eric Wrights in the world, but there's only one Disco Posse. That's the easiest way to find me. So if you search for Disco Posse, there's definitely only one of those on LinkedIn. And please, I recommend folks connect, watch other great podcasts. So thank you all for joining and sharing your knowledge and stuff today. And check out the webinar. It's fantastic. These are practical things. So this isn't just like, let's talk for 45 minutes on the ethics of AI and have no outcomes at the end of it. This is like, you walk in, we walk through hard problems, you show us how to solve those hard problems, and you give us ways to experiment. So this is practical for the best of us and for the rest of us. And thank you all for sharing this stuff. So with that, make sure you, of course, go get to your latest SNIA online and in-person event. So make sure you go to SNIA.org, check out all of the other links to upcoming in-person events. 2026 is going to be a great year in technology in the world. And I look forward to seeing all of you on many, many more of these kind of podcasts and IRL somewhere at a SNIA event.